In this video, we'll take a look at implicit differentiation. So it's differentiation of a function given explicitly instead of explicitly. So far, functions involving two variables have generally been expressed in explicit form. That means they've been solved for y. Y is equal to some function of x, in which the dependent variable y on the left is given explicitly by expression on the right involving the independent variable x. That is, one of the two variables has been explicitly given in terms of the other. For example, y equals 3x minus 5, s equals negative 16t squared plus 20t, or u is equal to 3w minus w to the third. They're each written in explicit form, and we say that y, s, and u are functions of x, t, and w. Many functions, however, are not given explicitly and are only implied by a given equation. For example, if we want to find the derivative, dy dx, for the equation x times y is equal to 1, this isn't solved for a particular variable. So if you could rewrite it by solving for y, and you get y is equal to 1 over x. If you can write it explicitly, then we rewrite this so we can use the power rule. Y is equal to x to the power of negative 1. When we take the derivative of the left-hand side, the derivative of y is 1, dy dx. So derivative of y with respect to x is dy dx is equal to, apply the power rule, negative x to the negative 2. So the derivative is a negative 1 over x squared. But what happens if you can't solve a function for a particular variable? So for example, I've got the function x squared minus 2y to the third plus 4y is equal to 2. We can't solve this function for y because we have a y to the third term and a y term, and no amount of factoring is going to allow us to do that. So what we do is the function is given implicitly, that means in terms of two variables, and we're not solved for one variable, and we use implicit differentiation. So to understand how to find the derivative implicitly, you have to realize that the differentiation is taking place with respect to x. This means that when you differentiate terms involving x alone, you can differentiate as usual. But when you differentiate terms involving y, you have to apply the chain rule because you are assuming that y is defined implicitly as a function of x. So here's what that means. We have terms x squared minus 2y cubed plus 4y and then equals 2. We're going to take the derivative of each of these terms individually with respect, derivative of y with respect to x. So with the x squared term, take the derivative as you normally would, 2x, minus, then when we take the derivative of 2y to the third, imagine that y can be written as some function of x. So think of it as the chain rule. Y itself represents a function. So the chain rule says we're going to take the derivative of the outside function, take 3 times 2, which is 6y squared, times the derivative of the inside function. We don't know what it is, so we express it as dy dx, the derivative of y with respect to x. So the derivative of the term negative 2y to the third with respect to x is negative 6y squared times dy dx. Now we take the derivative of the next term, 4y. Again, it has a y variable. So we take the derivative of 4y, which would be 4, and then the chain rule times dy dx is equal to the derivative of 2, the derivative of a constant is 0. So implicit differentiation means we take the derivative of each individual term with respect to x. Now what we're trying to find is dy dx. So we're going to solve this algebra equation for dy dx. To do that, take the 2x term to the other side, and we end up with negative 2x. Then factor a dy dx out of the two terms that contain dy dx. We're left with negative 6y squared plus 4. Then to solve for dy dx, divide both sides by negative 6y squared plus 4. So the derivative of my function dy dx is equal to the function negative 2x over negative 6y squared plus 4. And notice the derivative of the function is in terms of x's and y's, the same as your function was implicitly at the beginning, then your derivative is also an implicit function. All right, let's take a look at another example. If we have implicit derivative involving a product. So if we want to find the derivative of 3y to the fourth plus xy squared plus 2x to the third minus 6 equals 0, we're going to find the derivative of each individual term and then solve for dy dx. 3y to the fourth is in terms of y, so we take the derivative. 4 times 3 is 12. Y to the third, we apply the power rule, times the derivative of y dy dx. Again, we're taking the derivative of y with respect to x, so think of y as a function or as an expression. Plus, we have x times y squared. Now we need to use the product rule. So I'm going to take xy squared over here, x times y squared, product rule. You let f equal x, let g equal y squared, f prime is equal to 1, g prime is equal to 2y times dy dx. So with the product rule, we take the first, x, times the derivative of the second, 2y dy dx, plus the second function, y squared, times the derivative of the first. So this entire expression represents the derivative of the single term xy squared. So putting it in alphabetical order, we get 2xy dy dx plus y squared. Now we take the derivative of 2x to the third. It's got an x in it, so we take the derivative normally. We get 3x squared, or 6x squared, 2 times 3. And then the derivative of the constant is 0, is equal to 0. Once you've taken the derivative of each individual term, isolate the dy dx on the terms with dy dx on one side, take the y squared and the 6x squared to the other side. So that becomes minus y squared minus 6x squared. Factor dy dx out of the two remaining terms. We're left with 12y to the third plus 2xy. Then divide both sides by 12y cubed plus 2xy, and we end up with negative y squared minus 6x squared divided by 12y to the third plus 2xy. And that's our derivative. So again, it's in terms of x's and y's. All right, let's take a look at an example when we have the equation of a circle. Remember that the derivative is the slope of the tangent line. So if we want to find the slope of the tangent line to the circle x squared plus y squared equals 25 at the point 3, 4, and then find the slope at the point 3, negative 4. So here's my circle with radius 5 and my two tangent lines. So first thing I do is take the circle, x squared plus y squared equals 25, and find the derivative. The derivative of x squared is 2x, plus the derivative of y squared is 2y times dy dx, using the chain rule, is equal to the derivative of 25, which is 0. Now solve your equation for dy dx. Subtract 2x from both sides. We get 2y dy dx is equal to negative 2x. Divide both sides by 2y. We end up with the derivative dy dx is equal to negative x over y. So the derivative at the coordinate 3, 4 substitute 3 in for x, I'd get negative 3, 4 in for y. So the derivative, or the slope of the tangent line here, is equal to negative 3/4. At the coordinate 3, negative 4, dy dx would equal negative 3 over negative 4, which ends up being a positive 3/4. So the slope of the tangent line here is positive 3/4. All right, some of the practice problems, you'll have to use the product rule within here. So I want to take a look at one towards, let's see, any of these will work. So we'll do one or two of these, and then I'll write down the solutions for the others. So let's take a look at number 2. Number 2, we want to find the derivative of x squared plus y plus xy is equal to 3. Take the derivative of x squared, we get 2x. The derivative of y is 1, use the chain rule, times dy dx. Plus, the derivative of xy, we need the product rule. So let f equal x, g equals y, f prime is 1, g prime is dy dx. So when you use the product rule, you take the first, x, times the derivative of the second, dy dx, plus the second, y, times the derivative of x, which is 1. So there's the derivative of each of my terms is equal to the derivative of 3, which is 0. Now keep the terms with dy dx on one side and take your other terms to the other side. So I have dy dx plus x dy dx is equal to, take 2x to the other side, we get negative 2x minus y. Factor out dy dx. Remember, when you factor it out from this first term, you're left with a 1 plus x equals negative 2x minus y. Then divide both sides by 1 plus x, and your derivative is equal to negative 2x minus y over 1 plus x. All right, and then you would do the same for all the others. Okay, let me do one more. Number 5, we have to use the product rule twice. So product rule, x squared is f, y squared is g. So we take x squared times the derivative of y squared, which is 2y dy dx, plus the second, y squared, times the derivative of x squared, which is 2x. Those two terms are the derivative of x squared y squared. Plus 4xy, we need to do that again. I'll keep 4 with the x. So the first function is 4x times the derivative of y, which is dy dx, plus the second, y, times the derivative of 4x, would be 4y, is equal to the derivative of x, which is 1. Keep all the terms with the dy dx on one side. So I'm going to have 2x squared y dy dx plus 4x dy dx is equal to, take y squared times 2x, which is 2xy squared, to the other side. It becomes negative. Take our 4y to the other side, minus 4y, and 1 is already over there. Factor a dy dx out of the expression. We're left with 2x squared y plus 4x is equal to negative 2xy squared minus 4y plus 1. And the last step, divide both sides by 2x squared y plus 4x. And that's our derivative. So dy dx, cancel these,